The blueprints for the Taj Mahal describe a mathematical replica of the Islamic Garden of Paradise and the Throne of God. The complex spans 55 acres, ordered by a system of bilateral symmetry, where every courtyard, pathway, and water feature on the left has an exact mirror image on the right. This overhead architectural blueprint highlights how that symmetry was achieved. The designers relied on ancient units of measurement, the Mughal gauze and the older angula, to subdivide the plot into a precise, repeating grid, specifically positioning the Charbagh Gardens as a mirrored centerpiece. Notice how those geometric lines extend outward. Even the massive riverfront terrace and the main mausoleum itself are locked into this exact mathematical subdivision, positioned at the extreme northern edge to finalize the spatial formula. A building dictated by such rigid geometry should feel cold and imposing. Yet, standing in front of the Taj Mahal, the structure seems almost weightless. To find out why, we have to look much closer. The exterior is wrapped in Makrana marble, quarried hundreds of miles away in Rajasthan. This specific stone is famous for its high purity and fine crystalline structure. Because of that structure, Makrana marble is semi-translucent. When sunlight hits standard stone, it bounces off the hard surface. When light hits this marble, it penetrates the surface and scatters inside the stone before refracting back out. This microscopic cross-section of the marble's crystal structure shows how that refraction interacts with the atmosphere. At sunrise, the sun's low angle causes shorter blue light waves to scatter away in the sky. Only the longer red and pink wavelengths reach the marble, penetrating the crystals and giving the building a soft, rosy glow. By midday, the sun is directly overhead. The full spectrum of light strikes the stone with minimal atmospheric interference, bouncing back as blinding, pure white. At night, the weaker, reflected light of the moon shifts the visual output to a cool silver and blue. The entire building was meticulously engineered to act as a massive optical canvas that visualizes the Earth's constantly changing atmosphere. While that atmospheric effect dominates the exterior, the interior of the main mausoleum chamber focuses on a different scale entirely. The massive 55-acre grid shrinks down to a matter of mere millimeters. The walls are covered in pietra dura. It's an intricate stone inlay technique that originated in the Italian Renaissance and was perfected by Mughal artisans. They carved stylized botanical designs directly into the marble walls. Artisans sourced 28 different types of precious stones, including turquoise from Tibet, sapphire from Sri Lanka, and lapis lazuli from Afghanistan, slicing them into tiny fragments and meticulously locking them tightly together to form beautiful, perfectly seamless floral patterns. This dense visual detail is paired with precise acoustic engineering. The shape and volume of the chamber create a reverberation time of 28 seconds. When a designated reciter chanted prayers for the dead, the holy words would linger and continuously overlap in the air. The design pairs these hyper-focused gemstone patterns with a continuous 28-second wall of overlapping sound. Together, they create a sensory environment meant to isolate the observer from the physical world and simulate the richness of paradise. This top-down schematic of the inner burial chamber reveals the final placement of the tombs, exposing a single break in the complex's perfection. Mumtaz's cenotaph rests dead center in the geometric grid, but Shah Jahan's cenotaph is positioned off-axis to the west. Shah Jahan was buried there years later. Placing his tomb next to his wife's permanently broke the absolute mathematical symmetry that governed the rest of the site. The site's architectural legacy is found in this specific resolution of scale. From a mile away, its strict grids organize the geography. From the gardens, its translucent shell catches and broadcasts the colors of the atmosphere, and from an inch away, it dissolves into microscopic, interlocking gemstones. Ultimately, the Taj Mahal serves as a hyper-calculated machine designed to systematically alter human perception across every possible distance.